Hello, guys. Today we're going to introduce a new topic. We are going to talk about linear regression, and we're going to start this unit off talking about correlation versus causation. Now, you're probably wondering why I have a picture of an ice cream cone and a shark. Probably looks totally random. But actually, these two images are here because there was a recent study done that showed that when ice cream sales increase, the number of shark attacks that happen also increase. Now, that seems like a very strange thing to say, but after much research, it was actually concluded that that is very true. When ice cream sales increase, so do the number of shark attacks. Why do you think that could be? Take a second to think about what these two things may have in common and how they could be related. And we're going to further discuss this throughout this lesson. First, let's understand the difference between a correlation and a causation. Here you see the definition of correlation is a statistical way to measure the relationship between two sets of data. It means that the things are being observed at the same time. A causation means that one thing will cause the other to happen. So a correlation just means that two things are being observed at the same time, and a causation, one thing is directly causing the other thing to happen. So you can have correlation without causation. The correlation is simply the relationship between the number of shark attacks and ice cream sales. So if you haven't figured it out, people were able to make this conclusion because of when these events were observed. If you observe both of these occurrences during the summertime, you notice that ice cream sales go up in the summertime because it's hot outside. People are buying ice cream. And so that time of the year is when ice cream sales are up. Also, shark attacks typically happen on bodies of water, and during the summertime is also when people decide to go to the beach to get on boats and to do water activities in the summertime. So it is not necessarily that these two things are directly related. It is that when they are observed, they have a commonality, that these things are both popular during the summertime. And so that's how they can be connected, is that during the summertime, ice cream sales go up. During the summertime, shark attacks also go up. So this would be an example of a correlation. However, this does not mean that selling ice cream will definitely cause shark attacks. So there is a correlation, but there is no causation here. Now let's take a look at some examples here, and you're going to decide if this situation represents a causation or a correlation. Read number 1 and decide which you think it is. All right, if you look at this, you will notice that this is a correlation. There is a relationship between students in college who vote and students who do not, but one does not cause the other. There is no guarantee that just because a person went to college, they are going to vote. So that is not a causation, that is a correlation. Read example 2, decide is this causation or correlation? All right, here again, this would be a correlation. This is just an observation that there was more trash after second period than first period, but it does not mean that just because the periods change that there is going to be more trash. One event is not causing the other to happen. Here's the last one. Now, this would be an example of a causation. Hitting your little sister is definitely going to probably cause her to cry, so that is a causation. Now, what we can do with a correlation once we decide that there is one is we can measure it using something called R, which is a correlation coefficient. Your correlation coefficient is going to be some number between -1 and +1, and it's going to have the following 4 characteristics. It's going to have form, it's going to have direction, strength, and then something that is called outliers. Okay. In the next video, we are going to go over these 4 characteristics to see how they relate to correlations and causations.